Hello students, today our topic of discussion is preservation technique of chordates. I am Dr. Bhagyashree Mohanto, Department of Zoology, USTM, and this particular topic is for BSZ first semester students. First, we will going to discuss about the preservation method for lower chordates, and our first phylum is Hemichordata. After collection, for narcotization of that particular species, we need to place those specimen in a container of seawater and permit the species to expand completely. Then we need to add 10% absolute alcohol drop by drop over a period of an hour. Then in between 4 to 6 hours, complete relaxation of that particular species has been completed, and after that we can add 5% formalin to kill the species. Then the specimen may be preserved either 70% ethyl or isopropyl alcohol or in 5% formalin. Our next lower chordate phylum is Urochordata, and after collection of Urochordatan species, we need to narcotize the collected specimens. For narcotization and expansion, we actually have to place those collected specimen in a large volume of seawater, and then we need to add small quantities of chrome acetic fixative to the surface of the water. This will diffuse into the water and kill specimen within 30 minutes to 24 hours. We can add formalin if we don't have chrome acetic acid fixative. So formalin can be used as a substitute of chrome acetic acid fixative for narcotization process. Then the water is siphoned off without disturbing the specimens, and large quantities of chrome acetic acid fixative or 5% formalin is again added for its preservation. Now we will going to discuss about the preservation method for lower chordates like Cephalochordata, for example Amphioxus, and the preservation process is somewhat different from other lower chordates. For relaxing of this particular organism, particular Cephalochordatan species, specimens are first placed in 9 parts of seawater and 1 part of alcohol until they die. Then they were transferred into 50% alcohol and gradually moved up to 70% alcohol for long-term preservation. In the preservation method of higher chordates, we will first discuss about fishes, and the preservation method of higher chordates species are actually complex than the lower chordates. So here in fishes also the preservation methodology is somewhat different from the lower chordates. So before preservation, after collection, we have to kill the fishes, and for killing the fishes we have to leave them in high doses of anesthetizing solution. So basically we can use chloroform or diethyl ether as anesthetizing solution, and after we leave those species in that solution, fish body became relaxed, and at that condition we can preserve them in more natural state. So before fixation we have to kill those specimen in anesthetizing solutions. Then for fixation after killing, the specimen have to be placed in a wide mounted glass filled with the fixative solution. Glass bottle, actually we have to add here a wide mounted glass bottle. Then the fish should be inserted into jars head first to make them easier to remove from the jar in the laboratory. Care must be taken not to pack too many fish in one jar. The specimen should float freely in the jar to avoid curling or bending. Otherwise, the identification will be difficult if the body of that organism of that fish became distorted due to curling or bending process. So we have to take good care of it. So before immersing a large specimen, a fixative should be injected directly into the body cavity to facilitate penetration and preservation of the internal organs. So in large fishes, we cannot just dip the organism in a fixative. We need to inject the fixative inside their body so that the inside part of that organism also fixed with the outside part. Then optimum fixation time for fish under 6 inches in length is 1 to 2 weeks, and for fish over 6 inches in length, preservation time ranges from 2 to 4 weeks. After fixation of fish species, we need to wash them. And for washing, actually we can use 50% isopropyl alcohol. So specimens are thoroughly rinsed into 50% isopropyl alcohol, and the decanted formalin can be reused. The specimen can be rinsed by putting the jar under running water. Alternately, the jar is filled with water. After several hours, the water is decanted and fresh water is added. This is repeated for several days until no formalin odor can be detected. If during rinsing the specimen shows signs of deterioration, it is transferred directly to 50% isopropyl alcohol for final preservation. And after that washing process, now we can preserve our fish species. So for preservation, actually we use many chemicals, but normally formaldehyde and alcohols are highly used chemicals for preservation process of fishes. So first chemical is 10% formalin. They are slightly acidic and will decalcify and soften bony structure. The addition of a buffering agent helps to slow down this process. Then we can use alcohols such as ethanol and isopropanol. They are most commonly used fixative and preservatives of fish specimen, especially for skeletal structures such as otoliths are to be examined. Then we can use freeze in dry ice or liquid nitrogen preservation process. It is come under cryopreservation, and this is one of the best method to preserve the colors and tissues of the specimen. For preservation methods of higher chordates like amphibians, here also three steps are there to preserve the specimens. First, we need to fix the specimen, then wash it, then preserve it. And before fixation, narcotization is also there. And here also, like fishes, we should narcotize the specimen before fixation. For narcotization, we use chloroform and diethyl ether like in fishes. And then after narcotization, fixation is there. The chemical, those used in fixation process is normally formaldehyde solution. It is in 10% formulation. And then after fixation, washing is there like in fishes. So the washing mechanism, we use alcohol. We have to soak the specimen in alcohol out of the formalin before transfer. The alcohol should be changed after 24 hours. And after washing, we should preserve our respective specimen. Normally 5% formalin or sometimes 70% ethyl alcohol, or sometimes 40 to 50% isopropyl alcohol are used as a preservative for amphibian species. For preservation of reptiles like snakes and lizards, here also 3 steps are needed for proper preservation. First step is killing or narcotization. Here in snakes and in case of snakes and lizard, actually we can use 2 types of killing methods. First one is drowning in warm water, but this process is very slow and crude also. So we can use another kind of killing method, that is in giving injection of 10% neem-butyl solution or ether solution or chloroform solution, which directly kill the organism. Then after killing, we need to fix the organism, and for fixation of snakes and lizard we actually require 48 hours to 1 week. Uh, for different kinds of lizard and snake, the fixation time or fixation methods are different. For a small lizard, formalin injected in the body cavity or through a cut made on the left ventral side of the body. For larger lizard, injection of formalin is also used in each leg segment and just underneath the skin at the base of the tail. For snakes, 10% formalin injected in every inch along the length of the body cavity, or else they are cut on the left ventral surface of the body. These cuts should measure 1 to 2 inches in length. That should penetrate into the body cavity and should be about 1 in apart. So like this, we can fix our different types of lizards or snakes. And after fixation, actually we do not need washing process like in amphibians and fishes, because we did not dip the organism in the fixative solution. We actually inject them in their body, so washing is not needed here. So we can go to preservation process direct after fixation. And for preservation, for small and medium sized reptiles, 6% formalin is used, and for larger specimens we use 10% formalin solution. In the preservation process of reptiles, only snakes and lizards are not there. Turtles are also there. So turtles are somewhat different from snakes and lizard because it have a carapace over its body. So the preservation process is different therefore. So for turtles, first here also we have to kill the organism. So for killing the organism, same method like snakes and lizards we can use. We can use warm water, or we can use injection of neem-butyl alcohol or ether or chloroform, etc. to kill the organism. Then for preserving small specimens, when the specimen is dead, the head, tail and limbs are pulled out to the shell so that they are exposed. Then slits are made between the neck and forelimb and between the tail and hind limb. Then in that slits, formalin is injected into the head, neck and limbs. Then the specimen is placed directly in a jar with 10% formalin, and after several days the solution may be replaced by 6 to 8% formalin solution. For big size specimen, may be kept as dried or wet dry specimen. So this is the methods for preservation of somewhat different organism like turtles. Preservation method for birds are different from other organisms like fish, amphibians and reptiles. Many preservation technique is there, so we can discuss in our slide. So first technique is Study skins. It is the most traditional preparation of study skin, in which almost all the body inside the skin is removed and replaced with cotton, so that the final result resembles a bird lying on its back with its wing folded. So it is like a dry preservation technique, and this stereotypic posture was developed to enable many skins to be kept together in cabinets to protect them from insect and the light damage. The second one is complete skeleton. If a complete skeleton is desired, a flat skin may be prepared. All bones, muscle, digestive and other soft tissue is carefully removed, and the feather and skin are stressed flat and dried. Then ROM method. It is the more recent preparation method pioneered by Royal Ontario Museum, and the name of the method is coming from the name of this museum, ROM, where all bones for a complete skeleton were removed while also producing a round skin without bill or legs, that is called a rome. Then other type of preservation technique is also called as smooth. If one set of wing and leg bones remain with the skin, the preparation is called as smooth in North America. It is a North American preservation technique. The preservation technique for mammal are very important technique to understand, because it is mammals are very specialized creature in the world. The complexity is in higher level, so the preservation techniques are also different for different kinds of animals and different kinds of body structure. So there are many preservation techniques are there. So first one is entire fluid preserved animal, where we can preserve the whole body inside inside a preservative fluid like formaldehyde or alcohol. It is basically for the smaller mammals. So if we want to study the whole anatomy and histology of a particular mammal, then we have to preserve them entirely in a particular preservative fluid. The second type is study skins, like in bird. Uh, it is accompanying a skull and partial skeleton. Some bones remain in the skull for studying pelage color, hair quality and molting pattern. Then another type of preservation technique is mounted skins, which accompanying partial or entire skeleton. Some bones may remain in the skin dependent on the method of preservation or freeze-dried specimen. Then entire skeleton we can preserve for study anatomy or geographic variation or for age determination. At least one male and one female skeleton per species is recommended to study their anatomy and um, their sexual differences. When when the taxonomist goes in the field to collect different mammalian species, we need to understand different field techniques to preserve some specimen in the field itself. So some types of field techniques are listed in this slide. So first one is in field. The specimen is preserved in 10% buffered formalin. So we have to carry, if we go to collection process, then we need to carry all this buffer formalin with us, so that we can fix the species in the field itself. The formalin solution ratio is tissue per formalin solution is 1:12 for 10% buffer formalin, and we can also use 70 to 90% alcohol. Then for preservation in formalin, The body cavity can be filled with formalin solution by injection until it turgid and firm. So we must also carry injecting device so that we can inject all that chemicals inside the body cavity as well. Then some formalin may also be injected under the skin, so the body cavity, large muscle and organs are also fixed. Then we should also know the mechanism of intestine removal. So removal of the intestine prior to the storage of the animal in alcohol is recommended, because if in the whole species, if the intestine remains inside their body, the preservation process should not be complete, because inside their body, intestine, the preservation of intestine is very time taking. So we should remove them, because we basically need the entire outer phenotype of the organism for identification. So we did not need the internal organs, so we need to remove all that internal organs so that proper fixation or proper preservation will be taking place. For long-term storage of the fixed mammal, different types of storage fluids are used. So here also, in case of mammals, after fixation in formalin, the particular organism should be transferred into alcohol, and alcohol is the most desired alternative. For permanent liquid storage of specimen in alcohol, the following procedure must be followed. First one is, after fixation in 10% buffer formalin solution, the specimen is to be washed by keeping it in slowly flowing water for 24 hours for removal of formalin. And this particular step is similar with the fixation washing process of fish and amphibians, because here also, in case of mammals, we dipped the whole organism. In case of smaller mammals, we dip the whole organism inside the fixative tube. So we need to wash them so that all the fixative will gone out. Then next, the specimen is kept in distilled water for about 30 minutes. Exchanging the water twice produces the best result. Then with the formalin when the formalin completely removed, the specimen have to be transferred into 50% alcohol for 30 minutes, and then 70% alcohol for some times. And for long-term storage in a collection, a final transfer into 80% alcohol is recommended. Mammalian species are also preserved with skin and mounts technique, like in birds, but the condition of the specimen will determine whether the skin or mounting technique should be appropriate or not. Because if decomposition occurs in the skin become loosened, and hair of the carcass will fall out. And if in this condition, if skinning is done, then the specimen is very difficult for study, almost impossible to study the skin or mounted specimen. So for mounting, the standard method of preservation for mammals is that of the round mount or small mammals and the tan pelt for larger specimen. The taxidermy mount, that is lifelike pose, is not used in museum collections, since each specimen requires much more space for storage. For very small mammals such as shrews, can be preserved in liquid and dried mounted condition. The preparation of skins in the field is have many steps. So here in this slide, we are going to discuss about the preparation techniques. So first, after removing the skin from the animal, as much flesh as possible should be removed out without damaging the skin with their with hair roots. Then the skin can be dried in the sun, or if necessary, high over fire, either hung on a line or stretches between pegs. Then salting the skin will speed the drying process and temporarily preserve the skin. Areas that still have flesh or fat should be salted thoroughly. Powdered borax can be put on the skin to further preserve it. Alternatively, cold ashes from the fire can be used. When the skin is nearly dry, it should be folded with the hairy side together. Before bringing the skin earlierly dried in the field to laboratory, we have to go through certain steps again, and the steps consist of first is relaxation of the dry skin by soaking it in lukewarm tap water, usually for overnight. Then brief washing of the relaxed skin with soap and water has to be done. Then rinsing of the skin in a degreasing agent such as Versol or carbon tetrachloride. And if greasy, the skin are allowed to stand in those chemicals, Versol or carbon tetrachloride, for half an hour or so. Then drying of the skin in sawdust has to be done using compressed air to assist the drying and to blow the sawdust out of the hair. For preparing skeletons for preservation, we again need to go through many steps. The first step is to remove as much as flesh from the bone as manually possible. Then the specimen can be further processed using variety of techniques. These techniques may include some enzyme solution or sometimes maceration with and without heat, then with detergents or ammonia or bleaches, then burial in sand, soil or manure, or sometimes we can use dermatized beetle colonies to make the skeleton to eliminate all the flashes from the skeletons. Then after any of this treatment, then further rinsing of some hand cleaning may be necessary. If cleaned by beetles, the specimens usually are fumigated, then frozen or rinsed in alcohol to kill all the insects. Then the bones may be soaked in ammonia or chlorine bleach solution to deodorize. The resulting specimen are then dried with or without heat. Sometimes large, long bones are drilled and the marrow is removed to reduce the potential for migration of fats and oils out of the bone. So, my dear students, this is all about our today's topic, preservation technique of both lower chordates and higher chordates. For preparation of this particular PPT, I have consulted with two informative books, that is Animal Taxonomy written by Monidip Raj and Theory and Practice of Animal Taxonomy and Biodiversity written by V.C. Kapoor. These are very informative and pioneer book of taxonomy, and you can also go through these particular books for many other important topics of taxonomy. And that's all for today, and thank you very much.